for me, my startup journey only started about 18 months ago, and I was at university before that. But a lot of the things that I've been able to apply and how much I've been able to contribute in my team and the progress that we've made has come out through all these other experiences I've had in my life. But to begin with, I'll just tell you a little bit about Elite Robotics and what we do. So basically, we've developed our own low-cost autonomous vehicle platform that we can use in mobile service robots. So things like autonomous lawnmowers, package delivery vehicles, land surveying systems, things like that. And basically, this sort of came out from our knowledge, the knowledge that I gained in my mechatronics degree at university, and as well as my co-founders, around autonomous vehicles. So we've been in a really interesting position because over the last decade or so, we've seen a huge change in the hardware industry, especially in the price to performance ratio, embedded computer systems, sensors, all these components that we need in advanced autonomous vehicles or advanced automated systems. And so that's what sort of really brought about the existence of driverless vehicles, or like the practicality of actually building autonomous vehicles that can actually drive us around and all these new technologies that are coming out. But the thing is, and so we know this is going to be a huge industry because we've done heaps of studies on this, and so the Boston Consultancy Group estimate that the autonomous transportation vehicle industry is going to be $42 billion by 2025 and $7 trillion by 2050. And we've already had, large automakers have sunk billions and billions of dollars into development of autonomous vehicles. I think they've estimated about $80 billion, and that's just not the funding that we know. And this is only in transportation, so think about, I think a lot of you guys have defense backgrounds. I'm sure there's lots of defense contract work that's been done, not only in but like all over the world, into autonomous vehicles. And this has been going on for probably decades that we don't even know about. But there is some issues with the technology that's currently available. So if we take a look at, this is an Uber driverless car. So right at the top, that LiDAR that's sitting at the top there is an $85,000 LiDAR, or 85,000 US dollars. So that's a $100,000 LiDAR, plus all these little LiDARs that we have over here. I think there's about 6 or so of them. They cost about 10 grand each US. And then you've got those cameras that are sitting and there's like 12 of them or something like that. So these systems are so expensive. Just the sensors themselves are stupidly expensive. But there's a reason why they use these sensors, right? So if you think about when you're driving on a highway, so this is a comparison between a $10,000 LiDAR versus a $100,000 LiDAR that we've got, the Velodyne LiDAR that we've got at the top over there. And you can see the type of data you're getting out of this is significantly different. So if you had to choose a sensor that's going to give you more accurate information about your environment, it's a no-brainer that you're going to choose a $100,000 LiDAR, because look at the accuracy that you're getting. You need that when you're driving on highways, because your vehicle needs to be able to react very quickly to changes in the environment, because it's moving so fast. It needs to be able to see a lot further ahead than a slower moving vehicle would in a crowded city, for example. And then there's things like the camera systems that you have. So a lot of these systems, they leverage artificial neural networks to be able to perform object detection. These algorithms themselves are extremely complicated, and they take a lot of computational power to actually be able to run them. And so as a result, you've basically got to have a supercomputer in the back of all these cars. And I think it was the DARPA Autonomous Vehicle Challenge that they had in the US. That started in like 2003 or 2004, which is where all of this stuff kicked off from. So those autonomous vehicle engineers at Uber actually entered in that competition. And basically, what they did was, if you actually ever listen to stories about that competition, they literally had like massive server racks, and they were mounting server computers in the back of these cars. And then they had to figure out how to actually stop them from rattling around. And it's just crazy. And even now, with the changes in computing power that over the last decade or so, it's still like you still need so much computing power to be able to process all this information in real time. And then on top of that, the biggest challenge that you have with autonomous vehicles is actually taking all these data from multiple sensors and then fusing them together. So you need to be able to say, okay, I've got this information from this camera and this other camera, and I'll process them, but they'll process them at 2 separate times. And so obviously, the vehicle's moving 60 k's an hour. How are you going to figure out where that actual camera information is from? And so there's a lot of technical challenges around actually taking a huge amount of data and being able to process it quickly. So there's a trade-off between having all this data and actually being able to make the vehicle move around autonomously. So what we've sort of realized is that there's actually other applications of this technology outside of transportation vehicles. So like I mentioned to you before, there's land surveying, package delivery, and autonomous lawnmowers, or the lawn mowing industry. All of these industries, they rely on vehicles, ground vehicles, moving around and performing tasks. And now the same technology that you have in automating a vehicle, moving people, you can do the same thing. You've just got a different function that the robot's doing. But the problem is taking those big servers, computers, and having those stupidly expensive sensors, you can't really in a commercially viable way, apply that same technology into these industries. And so that's where we come in. And so what we've done is we've come up with a unique algorithm that allows us to extract information from lower resolution sensors that allows us to be able to actually navigate unknown environments, which means that we can enter these industries that traditional automakers or driverless technology cannot really enter. But something that I mentioned before about the highway driving, which is really interesting. So it's really interesting looking at how this technology has been developed within the driverless vehicle industry, because with Google, it sort of came out of their own, their Moonshot lab. So it was kind of like their research division that sort of came up with this. And I'm sure a lot of you guys can appreciate when you're building a product to be commercialized initially is very different to the roadmap you'd take if you're building something to see whether it's possible or not. And what we've seen is because they've led the way, I believe that a lot of other companies have been sort of following in their footsteps and trying to do what they've been doing, which has been really interesting. But what we've realized is that we can sort of work into start building this technology in different environments, so we can actually start adding value to customers in a shorter period of time. And so that's why we started focusing on the lawn maintenance industry, because we can actually constrain the environment that the vehicle's operating in. So while we're doing early testing and trying to assess the safety of the system, we can start working in a constrained environment such as farms, race courses, sporting venues, where you don't actually have people in that environment while the robots going around and mowing the grass. So you're still being able to add value to your customers without actually having a really sophisticated navigation system that can avoid moving people. And also, these vehicles are moving significantly slower, right? You're not going to have a lawnmower that's going to be moving around 100 k's an hour. And then so from there, so our plan is that we're starting within this industry so that we can start focusing in these really constrained environments and add value to customers, so we can shorten that gap from product development to actual revenue generation. And then from there we can start slowly moving towards more dynamic environments. And once the technologies reach that level of maturity, we can start looking at applying them into different verticals. So this is a little prototype that we've developed for our actual autonomous lawnmower. So initially we were targeting it at consumers, but once we started development, we sort of realized that even now the sensors and all this technology is a bit too expensive to target at consumers. So that prototype that we built, the hardware itself cost us about $2.5 grand. I'll show you some pictures of it during the development process in a bit. But yeah, so basically we've got a team that we've assembled. So we started off with myself and 2 other co-founders. One of my other co-founders is also a mechatronics engineer, and he started off, so that's Nathan, and he's actually currently doing his PhD right now. So we're actually commercializing his research that he's actually undertaking. And then our third co-founder is Luke, and he's an industrial designer. So actually, they started the company together without me before I even knew about it. So there was just one day that I was at uni, bumped into Nathan, and he was telling me that he was starting this company with his friend. And I said, oh, that sounds pretty interesting. I'd be really keen to get involved. And so we started meeting up and having a chat about things, and we're playing around with different ideas. So I think a lot of this came from the work that we'd done at university. So during our honours thesis, we had to do a lot of research, and we ended up reading all these PhD papers, master's papers, honours papers that people had written. And what we found was there was all this really interesting technology that's been developed, but no one was really doing anything with it. And we said, surely there's something that we can do with this. Maybe we can apply this in some way where we can actually start adding value to people, and take some of this research, this cool research that's been done, and actually apply it in the real world and get it out there to everyone. And so initially we thought about a vacuum cleaner that could go up and down stairs, but then we sort of realized that, well, one, we knew, that's all right, we knew nothing about actually build a vacuum cleaner. So we sort of just like, that's probably not the best way to start. But then after that, we started playing around with drones, and we started thinking, how can we apply the same technology in the drone space? But we couldn't really, we didn't really find something that sort of really stuck. And then Nathan, our co-founders, they both live on the Central Coast, and so they both live on like large properties. So Nathan lives on an acreage. I think the property he was living on was about a couple acres, and his landlord, they wouldn't let them use a ride-on lawnmower to mow the property because of the slopes that they had, and so they had to push mow their 2-acre property all the time. And so he was like, surely there's got to be a better way for this. And so that's sort of where the idea came into fruition, where we were like, okay, maybe this is something that we can actually do. And so I was still at uni at the time, but Nathan had finished his degree, and we were sort of just playing around with the, we started sort of working on it like once a week, a few hours a week and stuff, thinking about ideas and different paths that we can and how we'd actually develop this technology. But then sort of didn't really get too serious until towards the end of 2016. Yeah, it was towards the end of 2016. We entered into this course that the university was running with, in collaboration with Slingshot Accelerator. It was called Star 4000, and it was a course about entrepreneurship and innovation. And so we started doing this course, and we met Trent Bagnall, the founder, and we started. That was the first time we'd actually told anyone outside of our little group of people about this idea. And at the time, we were a bit hesitant because we were like, this is a bit crazy. Like, who's gonna like? Is this something that we can even do? We just graduated from university, you know, we don't have decades of industry experience. How are we going to be able to do this? But then going through the Lean Startup process, because they teach you all about Lean Startup methodology in that course, and they had all these different entrepreneurs come in and talk to us about startups and their story and building their startups. So we had like the co-founder of Canva come in. We had Ash Morrow, who actually, I think he invented the Lean Canvas. And as we were going through this process, we started to get the validation to say, you know what, actually, this is probably a good idea, and there's actually a demand for this in the market. And then through this process, through this course, we actually had a friend of mine that was also doing the course, and we ended up getting her in our group. And so she wasn't really involved in the project with us directly. But she was sort of came in from the outside, and there was a competition, a pitching competition that the university was running just after this course began. And so she encouraged us to apply for it, and we sort of didn't really, at the time we were like, no, we're probably not ready yet to apply for this, to enter this competition. But I'm so glad that we did, because we ended up winning that competition, and we ended up winning about $2,500, which gave us the first bit of money that we needed to start actually trying to develop this idea into something. But it also gave us the validation that we needed to continue forward, and as well as that, we were able to get 4 months of space at 376 Hub. So we were the first hub members at the 376 Innovation Hub. But since then, we've been able to grow our team to about 7 people. So we've got a communications manager who is also doing software engineering, and he's one of my friends that I went to uni with, and his girlfriend Jenny works with us, but she's actually based in the US at the moment. And then we've got Doug, who was actually our first mechatronics engineer that we hired. He's the first person that we hired in our company. And then we've also been able to bring on a financial advisor who used to be a senior consultant at PwC. So it's been a pretty interesting journey so far. But yeah, this is little pictures of our product development from when it began. So that lawnmower base, Doug was able to get it from one of his friends that he knew that lived on the Central Coast, with a lawnmower shop, and he just had this old mulching mower that didn't have an engine in it, didn't have any blades on it. So he got that for us for free, and then his dad runs a steel fabrication workshop, so he was able to fabricate some of the steel components for us. So we were able to sort of take something that was just a bunch of little pieces and an idea, and we managed to slowly evolve it into an actual lawnmower that we're able to move around and cut grass on its own. But initially, when we were playing around with ideas, we sort of thought, okay, if we want to do this really cheap, LiDAR's too expensive. Maybe we can just rely on machine vision completely. So I developed I used TensorFlow and Inception, which is pre-trained neural networks that Google created, and I retrained it to be able to identify grass, because we were saying, okay, if we can identify where all the grass is in a property, we can just invert that and figure out where all the obstacles are. But through that process, like what I mentioned to you before, we realized that it's just so computationally intensive, and you just can't run that on a low-cost computer. It's just not, it's not really realistic, although there are some techniques, new image processing techniques that have come out recently that might actually make that actually practical. But after that, from that initial stage, we started working on this a lot more, and we put in a submission to apply for the MVP state government grant, and we received the grant, which actually helped give us the money that we needed to hire Doug. It also gave us the money that we needed to continue developing our product and bring it to the stage where we could attract a larger partner that could help us develop out the product a bit further. But on top of that, through this process, we've been in a number of media publications. So New South Wales government did a press release on us. Plus we were in a local an electronics magazine that was distributed all around Australia. And then we were also in the Newcastle Herald and things like that, which has been pretty exciting. But yeah, so something that I recognised while I was at university, and that sort of helped me get to the position that I'm in, but also helped with us entering all these different pitching competitions and actually winning money. So this is a picture from our very first pitching competition that we won. And then that was another pitching competition that happened I think it was about a month later. So that was run by Dash at the Dantia Hub. And we came second and won another $1,000, and then also got some tickets to StarCon for that. And then about the middle of last year, we were New South Wales regional finalists in the Australia Post pitching competition. And for me, as I was studying and going through university, I didn't really I was always interested in science growing up, but I never learned how to code. I'd always been interested in it, but I was always just too lazy. Until I got to university, and that was like the first time that I ever seriously started looking at coding. And the thing is, with any kind of skills, any kind of skill set you have, and any kind of skill set you can develop, like, you know, it's so easy to look at people that ended up becoming entrepreneurs and running big companies when they're really young, like, you know, like Mark Zuckerberg and Bill Gates and people like that. But then you don't take into account that a lot of these people actually started developing that skill set when they were like 10 or 12 years old, and they've been playing around with computers and they've been coding. And so there's, you know, it takes time to develop these skills, and it doesn't just happen overnight. So you can't bridge that gap. So there were people that I was studying with that had been learning to code since they were old, and I realized there was no way I was ever going to be the level of work that they were doing and where I was at. I wasn't going to be able to catch up to them and be able to compete with them. I worked really hard, and I obviously learned how to code, and I learned to develop these technical skills. But I always knew that technically they were always going to be a little bit better than I was. But I sort of realized as I was going through university and I found out about TED Talks, and I started watching all these TED Talks, was that a lot of these people that give TED Talks, like, yeah, they're brilliant people, but they're not necessarily the people that are doing the defining things in their field. Because a lot of those people that are really, really, really good at what they do in the industry, they're not necessarily the best communicators, and they're not necessarily the best people to be able to communicate what they're doing. And so a lot of the time, they don't actually get the credit for the work that they've done. And I sort of recognized this lack of communication skills, particularly in a lot of the engineers that I was working with. And I realized that was something that I was always interested in. And I said, you know, I could potentially, you know, by focusing on that, I had the opportunity to be able to cut through that noise and actually do something with the engineering work that we were doing. And I started focusing a lot on developing those communication skills while I was at university. And so, and that's sort of what helped us get to this position. So I went to this talk about presentations, and the guy was saying that apparently I can't remember the exact statistic, but it was something like, people are more afraid of giving presentations than they are of dying. And when I found out about that, I was like, this is so ridiculous. But I was like, well, hang on a second, if I can get over this fear and I can actually get good at giving presentations, then I'll have opportunities that people would just be too afraid to be able to take. And so I focused really hard on that. And so while I was doing my honours thesis, I actually, the way the thesis sort of worked was that all your marks were actually on the project itself, but you did have to give presentations at the end of each semester, but those presentations didn't count towards your mark at all. And so I used those as opportunities to practice. I practiced learning how to give presentations without having a script that I was just reciting. And I also did that, so I used to play piano. I mean, I still do, but I've been playing piano since I was in year 8. And so I've been playing piano for about 10 years. And so towards the end of my degree, to make a little bit of money while I was still studying, I started teaching piano at a music school. And so what I found was at this music school, most of the kids that were getting piano lessons, they weren't really, they didn't really want to get piano lessons. It was just their parents were forcing them to do it. And so I'd be sitting there with them and I'd teach them a C major. And the next week, I'd be like, okay, play the C major scale. And they would be like, they wouldn't remember how to do it. And so I said to myself, well, I want to make this interesting for myself because I value my time. So I'm not just going to sit there and just go through the same thing over and over again. I'm going to try to find a way to actually add value to myself in this way. So I started focusing on trying to actually get them motivated and get them interested in playing piano and actually teach them something that they could actually use as they, even with music or anything that they could potentially use the knowledge they were gaining in some other way later. And I sort of approached it with the idea, so we'd already been sort of started talking about this business at that point. And I approached it with the sort of intention that, if I can get these kids to be kind of interested in this, that's a valuable skill that I'm going to need, because if I'm building a business, I'm going to need to be able to sell this to other people and be able to communicate to other people what, communicate our business effectively to other people and get them interested in it. And so what I did was, through that process, I was able to actually hone in some of those skills and get a lot better at it. So when I started teaching, I was only teaching about 6 students at the time, and then by the end of it, I doubled that. I had 12 students, and some of my students were actually told me that the only reason they kept getting piano lessons was because I was teaching them, and I actually ended up filling in for some other teachers at the school and ended up poaching their students because they liked me more. But sort of formed a real fundamental for what we've done, what opportunities we've looked for, and we've been able to get a lot of seed funding, a lot of funding through the actual process of actually pitching. And that's super important when you're going to pitch to investors, because you have to be able to effectively communicate your business to these investors that you want to get money from. But yeah, and so after, towards the end of last year, this Slingshot did an accelerator program in partnership with the University of Newcastle. And we ended up going into the accelerator program until we were able to get a bit more seed to continue our development, but they also helped us get to the point where we understood the type of documentation and things that we'd need to actually go and approach investors and what they would be looking for. And so basically right now where we're at is we've got the small scale prototype. We're in the process of building a much larger one with a partner. And we're aiming to have 5 beta units out in the field by the end of this year. At least sell them by the end of this year, with the aim of delivering them at the start of next year. And then towards the end of next year, looking at doing our first low volume run. So we've already had a few interests. We've done some work with, obviously, the University of Newcastle, doing some testing with them, but also Dubbo Council and Merriweather Golf Course. But we've also had a few farmers come and contact us our technology and actually getting a large-scale lawnmower for their property and maintaining it. So that's pretty much where we're at the moment. But yeah, so that's my startup story. Does anyone have any questions?
Yeah, I've got one. Have you got a strategic view of what would make a perfect client to work with at the start?
In terms of like customer,
yeah.
For us, it's mainly focused around sort of like the agricultural space, so like solar farms and just other traditional farms. So we've had some turf farmers come and contact us about cutting their property, cutting grass at their property, and things like that.
Sorry, you said you realised you couldn't use vision, so you're not switching back to LiDAR, is that what you...
Yeah, so we're not, and so that's part of the reason why we sort of are targeting that sort of larger B2B sort of space, because we realised that we weren't going to be able to develop our product at that small, that lower price point, but with a larger system, there's more opportunity to be able to have a more expensive autonomous system that is capable. And so we've ended up switching back to LiDAR, but we're using more expensive LiDAR.
In terms of competition, you didn't really talk about sort of who you're competing against. Are you truly novel out there? Is no one else in this space?
No, so there are competitors in the space. So there's a lot of consumer lawnmowers that have been around. So Husqvarna started selling theirs in 1995, but their system hasn't really changed at all since then. And most of the consumer ones exist. There's John Deere, Honda has some. I think there's like 40 different types that are on the market. But pretty much all of them, they work on a bump and go type system, so they don't recognize obstacles until they bump into them. And what they do is, and then you've got to have perimeter wire around the boundaries of the area that you're operating in. Yeah. So they'll either bump into an obstacle and turn 90 degrees, or they'll bump into perimeter wire and then turn 90 degrees. And they'll just keep doing that with the assumption that over a long period of time, they'll eventually cut all the grass. Yeah. So it's not the most effective solution. But then there's also in the commercial space, there are a few companies that are developing autonomous lawnmowers. Yeah. But what we've found is their technology is not that sophisticated. They're not doing it the way that we're doing it. And a lot of them, you have to pre-map out the environment. So if you change the environment, you've got to remap out things. And then also, most of them also still rely on perimeter wire.
What sort of interest you had from customers in terms of from the commercial aspect, so that you go into low rate initial production, you're looking to sort of move into a production selling environment?
Yep.
Is it proven to be what you thought it would be in terms of the commercial demand and price point?
Yeah, so surprisingly we found, we weren't really 100% sure about it to begin with, but we've had a lot of people that have actually come in contact with us, and the partner we're actually working with was actively looking for robotic lawnmowers, so they distribute them. They distribute lawnmowers, and they're actively looking for it because they could see that's where the future of this industry was going. Right. So because we were in the paper, they found us through that and got in contact with us. Mm-hmm. Yeah.
There's 7 of you in the team, is that right?
Yep.
How are you eating at the moment?
Yeah, so we all have other jobs at the moment, and yeah, so everyone works another job, and so that's what we've had to. It's been interesting trying to, because I manage a lot of the workflow and things like that, and so we've had to be very resourceful in how we use our time to make sure that we get what we can get done. To actually get us to that next stage, but right now we're actually doing the seed round so we can actually get people working full time in the company.
Right, so how many hours a week, how many man hours a week are you getting?
Yeah, so I've been doing 3 days a week, and so has one of my other co-founders. The co-founder, he's doing his PhD still, so even though the work he's doing is directly applicable, he spends a full day with us, and then the rest of his week working on his PhD. And then the other guy sort of about 1 to 2 days a week. And then Doug, our engineer, he works with us 3 days a week. But usually you just end up just doing work as you need to get it done. So it just ends up just being like, just working all the time.
So if you were to raise the funds, would you all quit your job and do it full time?
Yeah, so my contract with the union actually finishes this week, so I'm going to be working full time with Elite Robotics now. Which is, I think we're at that point where I sort of need to be doing it because I'm engaging with investors and actually doing the capital raise. And so the more time I spend on it, the quicker we'll get through that process and get it done. Yeah.
So just follow up on that. Could you go just one slide before? Like at the top there, you're talking about 350 to 500,000.
Yeah.
What's your plan?
Yeah.
How are you going to raise this amount of money?
So through going through the Slingshot Accelerator program, we've had their fund invested in us to go through the program, but they've committed to follow on. So we got some of the money through that. And then I've been approaching investors and talking to investors, but also I actually just recently got a scholarship with the City School of Entrepreneurship to go over to this go over to China on this program and to actually go to pitch to investment groups over there. So we'll be pitching to like Fosun Investments, Tencent, and then there's a few other ones that they're still organising as well. So yeah, so that's the plan. We've been fortunate that it's been interesting because a lot of startups that I've spoken to, people that tend to go into startups tend to be in their in their 30s, you know, have been in industry for a while, and so naturally through that process they've got connections in all these different spaces, and that's helped them a lot. They've been able to leverage on those connections to find investors and things like that, or even people they knew that they went to school with or university with that ended up making a lot of money, and then they have, you know, 100K that they can put in, and that's given them that additional money that they needed. Whereas for us, we haven't been in that position, and so we've pretty much from the start of this whole process, we've had to build our network from scratch. And it's been really good being at 376 Hub, because with all this innovation stuff that's been happening, there's a lot of people coming through the space, and through that we've been able to make a lot of connections and also plug into the innovation ecosystem all around Newcastle and the Hunter region. So we've got the opportunity to actually reach out to a lot of people, which is
How much
good.
equity offering?
Yeah, so what we're doing is we're looking at getting about a $3 million valuation, so that's just a little over 10%. Yeah.
Sorry.
So that's that $3 million valuation which is pretty standard from companies that come out of Slingshot Accelerator. So in the investment process initially, that they tend to have their companies that do go on and get follow-on funding after the program tend to have a $2.5 to $3 million company valuation. Yeah.
How are you protecting your IP?
Yeah, so it's pretty interesting because Nathan's doing his PhD on this area, which means that he has to publish papers on it. But the thing is, the way that he's doing, he's focusing it on a different area to what we're doing, and a lot of that is mostly talking about the theoretical aspects of it, so not the actual practical implementation. So a lot of and the reason why the way we built this platform is such that a lot of it is reliant on the mathematical models you build with the real world, and so you can make the platform do something completely different, like, you know, doing package delivery as opposed to cutting grass, and it's just a matter of adapting the actual dynamic model of the system. And so a lot of those parameters for those for the model comes from actual real world experiments, and so that's stuff that we can keep sort of trade secret. But it also means that there's a gap from what talks about in PhD paper to what we're actually implementing. And then to add to that, we've got a specific sensor configuration that's designed for our platform, and so we're filing a design patent for that specific sensor configuration. But then there's also other software protection mechanisms that we're looking at implementing to prevent reverse engineering.
Are you partnering with any existing Lawnmower people so that you don't have to go and develop that base level tech?
Yeah, so that's what we're working on at the moment. So that's the partner that we've been in contact with, that we've been talking to. Yeah.
And are you looking at the next step beyond lawn mowing already? Like are you offering to mow Rayfield and BAE and Bowden's lawns out the front, pushing for bigger work?
Yeah, well, looking down that path, we're still pretty deep in the product development phase. So that's been our primary focus at the moment.
You mentioned a bit earlier when you were talking about your competition that like other people in the marketplace were using technology that was not obsolete but not as advanced as you. Also, do you see what you're developing as a game changer?
Yes. Yeah. And another thing that helps with the protection, the IP protection, is it's the technical debt that has to be overcome to be able to implement this stuff. It's quite complicated, and it's not that easy to replicate. So people can copy the physical design or whatever, but that's not where the key to it is. It's all in the software. Yeah.
All right, I think we might wrap it up there. Neki Sahil.